If you ever run into a split pair, then what you're looking at is simply a cabling mistake. Someone has made a mistake on both sides of the cable and have taken pairs that would normally be twisted together and has moved them so that they are actually twisted with a different pair of cables. You certainly don't want that to happen. One of the challenges in troubleshooting a split pair is that if you were to plug in a device to perform a wire map from one end to the other, the wire map will pass. It will show that pin 1 is connected to pin 1, pin 2 is connected to pin 2, and so on. A normal continuity test and a wire mapping test all come back as completely normal. You'll need another type of test equipment to be able to determine that a split pair actually exists. If you have split pairs on a wire, what you'll start to see is poor performance as that wire gets longer and longer. As the wire is shorter, you don't tend to see as many performance issues. That's because the issue you run into is near-in crosstalk. As you're sending that traffic further down the line and subjecting all of the wires inside of the particular cable to that interference, you don't have the twisted pairs that normally would make up for resolving some of those communication problems. So your near-in crosstalk is much, much higher and your performance becomes worse and worse. It's those twists that's the secret. And if you in any way get rid of the twists on your twisted pair cabling, you're not going to have the performance you might expect. Let's look at a connection that's perfectly normal. We're plugging in a patch cable and we're plugging in an Ethernet connection that does not have any split pairs on it. You would expect that your straight through cable would have the normal green, your split orange between 3 and 6, your pair on pins 4 and 5, and the brown pair on pins 7 and 8. And if we were to look at the connection that is made between your network interface card and a switch port, you would see that those pairs line up perfectly. You're transmitting plus and minus on the green pair on pins 1 and 2, and your receive from your network interface card, your plus and minus, is on pins 3 and 6. Those pair, of course, are paired together and twisted all the way through from one end to the other. In a split pair environment, it looks a little bit different. You still have all of the pins connecting as they should. Pins 1 go to pin 1, pin 2 goes to pin 2, and so on. But notice you have a split here. Normally, instead of having your green pair go across 1 and 2, your green pair now are going across 1 and 3. And that means that the transmit that normally goes across 1 and 2 does not have that same twist and does not have that same cancellation that would normally go into effect. And so what you end up having is still connectivity between your network interface card and a switch port, but you don't have the advantage of twisting that signal between the plus and the minus all the way down the line. And that's why, as this particular wire gets longer and longer, you will have more and more near-in crosstalk, and it will be worse and worse performance as that signal goes farther down the wire.